Okay, so here we are here with SJPO 2015 Q1. So we have two identical masses and they are tied to two strings, right? One of them is attached to the center and one end is attached to A, and the other string, one end is attached to A, the other end is attached to B, and they're both spinning on this disk at constant angular velocity omega, the same constant angular velocity omega. And the reason why they're on the disk is to prevent them from falling down, right? So basically, we're only concerned with the XY motion of this, right? The 2D motion of this. So we are given that the tension between A and the set the tension between A and the center, right? The string connecting them, the tension is T. And so we're asked to find the tension of the string connecting B and A. So let's consider the force body diagram of A. Right, so a force body diagram of A, if this is the center, towards the left is towards the center, then there's T, a tension of T acting towards the left, and there's another T prime acting towards the right. We don't know what T prime is right now, so we're letting a variable represent it. Okay, so we want to, in the end, we want to express T prime in terms of T, right? As you can see, all the options here suggest, right? And so yeah, so what would a force body diagram imply, right? It will imply that if the net force acting on A, T minus T prime, right, towards the left, taking leftwards as positive, the net force acting on A must be the centripetal force required to keep A in a circular motion. Right, in this case, the circular motion is at radius r. So that means that T minus T prime must be m omega squared r. Okay? And so this, if you're confused by why this isn't 0, right, and why is this m omega squared, I'll refer you to the previous video where we reviewed the concept of centripetal force, right? This is the centripetal force. The centripetal force is provided by the T minus T prime, right? And the centripetal force is equals to this because that's the amount of centripetal force required to keep A in at a constant radius of r, right? And spinning at an angular velocity of omega squared. So this is our first equation, right? And so let's consider the force body diagram of B. Right? B only has T prime acting towards the left, right? Yeah. So the net force acting on B is T prime, right? Taking leftwards as positive, taking towards the center as positive, right? Then this will be equals to the same mass m, right? The same angular velocity omega squared, but this time the radius is different. This time the radius is 3r, right? Instead of r. So this is 3r. And so it may seem like we're done over here, right? We have just found T prime in terms of these variables, but unfortunately the question wants us to find T prime in terms of T. You see all these options here suggest, right? So we just need to express T prime in terms of T, and to do so we can take the first equation over here and we can rewrite it such that 3t minus 3t prime is equals to 3m omega squared r, right? And we know 3m omega squared r is equals to T prime by this equation, right? So from there, we can rearrange it so that we just have 4t prime equals to 3t and t prime equals to 3 over 4t. Okay, so hence the answer is B. I will see you in the next video.